Hello, I'm Chiranjib Sengupta, and you're with me on the Energy Connects podcast. Welcome to the first episode of a special series brought to you in partnership with Siemens Digital Industries Software. In today's episode, our focus is on incorporating digital twins into oil and gas operations, the unique benefits that such a scenario can provide, and how digital twins can also help make the industry more sustainable. To discuss these and a lot more, I'm delighted to welcome two industry stalwarts from Siemens: John Nixon, Vice President of Global Strategy for Energy, Chemicals and Infrastructure, and Mike Houghton, the Global Head of Sales, both at Siemens Digital Industries Software. Thank you, John and Mike, for joining us on the Energy Connects podcast.
Happy to be here.
Good to see you again.
Now let's start with the very basics. Could you explain the concept of a digital twin for an oil and gas business employee who might not be too familiar with the term?
Mike, I'll go ahead and take a first shot at this. The interesting thing about the digital twin, if you were to have 10 people in a room, you'd have 10 different answers as to what the digital twin is. A lot of people view the digital twin as a visual representation, right, of the physical world, if you will. What I would say is, in my experience for energy, chemicals, and infrastructure, the digital twin represents the sum total of all the data that's been created around a single artifact, a single asset. For example, if you have a valve, you've got design data for that valve, you've got installation data for that valve, you've got maintenance data for that valve. And when I say the design data, you've also got the geometry and the actual CAD around that valve. So yes, there is a physics or a geometry around that asset, but there's all the data associated with that asset. And so with the digital twin, you'll find paired with that term, the term life cycle. And so there's an entire life cycle around an asset. Now, an asset is not just like a piece of equipment, like I just shared, a valve. An asset could be a single artifact. It could be an entire system. You could look at a system, and you've got a digital twin of that system, and then you've got a system of systems, right? And so we often call those a chemical plant or a power plant and so forth. So a digital twin is also a matter of scale. So you've got scale effects. What am I looking at here? A single item or a system of items? And then what is all the data associated with it across its life cycle? Mike?
Yeah, you are correct. Digital twins are very often described very differently depending on whether the lens you're looking through. What I like to do to try and keep it simple is, it's basically a virtual representation of either a piece of physical plant, like the valve you mentioned, the equipment, or it could be the product and the process used that flows through those valves and those different assets. I think the thing you've got to think about long is why this should be of interest. Digital twins allow designers, engineers, operators, and maintenance staff really to get their hands on data in a way that brings a lot of value to the overall production process. Or maybe even to the design process. When I think of digital twins, if you've got all that composite data you mentioned earlier, John, and really begin to come up with scenarios to get the best solutions. It's in the design cycle, but it's also when you go into that maintenance for that artifact, as you mentioned earlier, you're inheriting all that data that was born in the design process, and it's really allowing you to I'm going to say to maintain your asset much more productively than what you were able to do in the past, which is paper-based systems and the likes.
Well,
So,
and I'm glad you said that, Mike. It's not just a static image or a static geometry. It is a dynamic and virtual representation. So as you said, it's not just the asset itself, but it could be the actual product or the action of said asset, within the system. It's all part of the digital twin. So it is very much a dynamic, and the value of a digital twin, I'm glad this question was asked, because the value of the digital twin is seen in your ability to keep it, let's say, in sync with the physical reality. So if you have activities in the field, you could have things like inspection and tests going on, or operations, right? You've got sensors and so forth. So you've got live data feeds, you've got personnel in the field. So with a digital twin, it's imperative that you have, I guess, for lack of a better term, we hear this often, real-time data, right? You want it as near real-time as possible, so that when everybody and anybody is looking at the digital twin, they know that it is truly a virtual and dynamic representation of the actual physical reality on the ground.
Yeah. I think, just to finish off on this question, because it is fundamental to everything we do. And the fundamental reason why this is important is it allows customers really to drive innovation and unlock productivity by having access to all that data. That's really what it's about for me. And we're going to talk about this, I guess, a little later. It's how that data is made transparent across the entire life cycle you mentioned. That really is the the golden nugget that customers need to understand. It's how you avoid having data jails and how you have those digital threads across the entire life cycle. And if you get that, you've got real innovation and productivity in your grasp.
And that's a great point. And adding to that, what are some of the unique benefits that a digital twin can provide to oil and gas operations, and can such benefits also extend to remote operations?
That's a great question. We need to understand, for the digital twin, it's one thing to have it; it's another thing to apply it and to be able to use it. Right off the bat, I think it's fairly common knowledge that if you're going to apply digital solutions to physical problems, you need to look at things like, predictive maintenance and operational optimization and remote monitoring and so forth. And then when you look at the humans that are part of that, you look at training and knowledge transfer. You know what? When I think of the digital twin in oil and gas, or really any energy subsegment, I think about the broader metaverse that digital twin is a part of. And if you think about it, we talk a lot about the industrial metaverse, which is really digital twins at scale. And it promotes the ability to provide contextualization. And that's so very important to the digital twin, is to have context. Now, we talked earlier about, the life cycle of data. Mike talked about how the dynamic systems and the digital twins of those, and driving better yields and better productivity. So the benefits of a digital twin, depending on your background, we're all victims of our own history, right? And our own experiences. I come from, spending a lot of time out of the 32 years I've been out of college. Most of that time was spent in the field with laborers, with welders, with pipe fitters. Actually designing, constructing, managing change in the field. And so I tend to think of the digital twin as something that's got to be available to field personnel at the work face. So for me, if I've got a digital twin, I've got the life cycle of data that is associated with that asset. I can put that little engineer, I can put that little guide on their shoulder, and provides an assisted reality environment for laborers in the field, for personnel that are really have wrenches and hammers, and are responsible for creating that physical world that you're now going to build a digital twin around. So I look at the safety aspects of it too as well. When you have, I was in the Middle East about 6 months ago, and there was a pervasive conversation about a competency shortfall that came up. And what they meant by that was, they have very transient labor at certain job sites, right? So, people will come on shift for several weeks or several months, and then be off shift and come back. And so when you have that kind of rotation, there's inherent hazards with that. And so, the job site, the situational awareness of that job site has to be, brought to bear quickly for each of the personnel, so that they operate safely and productively. And so the digital twin, if maintained in sync with the physical reality, allows, in this use case, a very rapid assessment and training to drive situational awareness and safety and productivity for transient staff that are on rotation. For me, the digital twin, when you think about the benefits of it, I think about safety. I think about productivity of personnel. Mike, you're probably thinking of it also in terms of, as you said from your earlier example, production and yields and profitability.
Yeah, yeah. I mean, I actually, yeah, I do think of those, but if you take your paradigm, you're starting from the field side, which I spent a long time in the field. Uh, not probably not quite as long as you, but then I spent a lot more time on the design and implementation side. And if I think of it there, and this particular question around how they can benefit not just operations, but those remote users, right? If I think back to the design side, we've got platforms, John, where we know we can have collaborative teams working together 24/7. And when I mean 24/7, that collaborative platform will give access to multidisciplinary, should we say, engineers. That might be piping engineers, automation engineers, process engineers, mechanical engineers, all working in the same environment on that digital twin in the design phase. And what's more, we can follow the sun. We can work 24/7 as the demands might dictate. So we can get rapid deployments from all those remote users around the world working on the same system in a real-time environment, building up that data. Now, when we build that data up, we're actually just adding to that digital twin data as we go on and build this. And that's in the design cycle. Now, that information through those digital threads we spoke about earlier will allow those maintenance and operational staff access to the real as-built data. And, you can typically, you know, um, if you look at a maintenance engineer, their wrench time, that's actual time actually carrying out maintenance. And it's normally around 20%. They spend the rest of the time
Yes.
collecting data, getting work permits. Is that data the right
Right.
as-built data? They go out and do a check. There's a whole host of things. And then after they carried out the maintenance, they've got to have a lot of reports and record the data back into the system. Now, with that digital twin data and the artifact information that we've have built it across the entire life cycle, we can actually flip that. So they can actually spend 80% of the time actually doing the wrench time, doing the maintenance, because they've got all that data already available, and only 20% is therefore spent on the admin and the associated documentation and evidence collecting required for the maintenance activity. So that's just a little example from how it goes from design right the way through, and how we can work 24/7 and the likes.
Mike, as you were talking about that, it reminded me of a study I had to do on time on tools many years ago. And it's surprising the variability of productivity you have between shift change, between various shifts and between various companies. But I always found it surprising how little time. I mean, that's a relative statement. I mean, yes, there's a lot of work being done, but the efficiency, right, of
Without
time
that,
on tools was rather lacking. And uh, making sure you had, the right information for the right work to be performed and the right tools for that, you're absolutely correct. And then, the beauty is with the digital twin, if you have a means to extend it to the work phase, as I was talking about earlier, the that should and will increase that productivity. It will improve your time on tools, and making sure that not just time on tools, but that the work is getting completed correctly the first time. So, for me, we say unique benefits about the digital twin in oil and gas, and I would say that these aren't going to remain unique per se, in that it will become standard. I think is the description I would choose. It's going to be in the everyday. I mean, the next generation of staff that's going in the field, well, they were raised on Xbox and PS4s, and the expectation of this kind of digital world. There are AI agents within those games that would guide people as they play, and so it manifests into expectations of what do we have in industry. So it's very exciting to see that the digital twin, while it was notional 32 years ago when I, left college, has really become institutional now in everything that we do.
John, I was sharing a keynote speech with a CEO of a large chemical company. He described it as the largest chemical company in the world this week. And we were talking about digitalization and productivity and how this helps support him in his business. And I made the comments because I used to run some factories many years ago, and we drove digitalization quite hard there. And we were delivering productivity of between 4 and 7% a year, which we thought was good. But automotive, which really is a leader in digitalization and digital threads, they were delivering between 8 and 13% year on year. But they could only do that with a good digital backbone that allowed them to do digital threads of all their digital twins. And it was really driving their productivity. Anyway, this guy at this largest chemical company in the world, I said, what would you do to get those sorts of productivity gains? And he said, Mike, we're happy with 1%. And I was like, wow. And he said, the room for improvement is huge. And I would say that to all process sector customers, not just oil and gas, is the opportunity here to unlock potential in terms of productivity is huge. And we've really got to grasp it. And it's just how you grasp it and move that forward.
Well, it is. It is a strategy. In fact, I was just at a Reuters event yesterday, a data-driven oil and gas. One of the things that came up as a quote was, if you don't have a data strategy, you don't have an AI strategy. And so, I think with data strategies, you have to consider your digital twin, and you have to consider how that's going to power your future AI investments. So you asked a great question, what are the benefits to oil and gas around the digital twin? Well, the digital twin is the foundation you're going to lay for future investments in AI. I mean, every time we get up in the morning, there's another headline about artificial intelligence, some new development, some new capability. Somebody else has released a new version, and it's like an accordion. I feel like, we had a lot of digital innovations in the 80s and the 90s and early 2000s, not to show my age, but it's like that accordion's getting squeezed, and we're starting to see the frequency of innovations around digital, and the digital twin is just it's almost, it feels daily. I got to tell you, you wake up in the morning, there's some new headline somewhere, and it could be something with DeepSeek out of China, or something coming out of Europe, or something coming out of the US. And it's just amazing to me, the pace of innovation. We've read about it. We've talked about it over the years. We're living it right now. And so it's a rather exciting time. And the digital twin, like I said, it's no longer this notional discussion. It's actually mission critical. If you're going to be competitive in oil and gas, it's mission critical at this point. I was at another event about 3 months ago at a dinner, and one of the small to medium companies that was in attendance said, we still work with contractors that don't even use smartphones. All right, they're still using paper and pencil, or pen and pencil, or pen and paper, I should say. And I just found it interesting. I know, right? I can't even say pen and paper anymore, right? It's all digital. But I find it interesting that you would still have people, even in the field, that aren't finding a value or finding it mission critical to use digital. Well, it's becoming that way. The expectations for safety and reliability and productivity, and the fact that it's in our everyday life. In the past, without Starlink, you would have said, well, I'm out in the field. There's just no connectivity. It's better for me to capture the data manually, and then I'll go keystroke it in later on into Microsoft Excel or something like that. And then you have, thousands of worksheets and thousands of workbooks with worksheets on laptops and computers, and you're losing, data fidelity. Now that our world, again, this accordion of innovations that's going on, um, we're gonna have Wi-Fi on every square centimeter. See, Mike, not square inch, square centimeter
No inches.
of the planet. And so it's life without the digital is going to be near impossible, quite frankly. You won't be able to do your job without it. So you've got to have you've got to have a data strategy. You've got to build a digital twin as part of your foundation to your longer term investments that everyone will be making in the digital space.
Yeah. I think, as you say, customers that don't have that strategy in play are really going to struggle in the future. I think it's going to become so stark that people that have got that forward thinking strategy and the ones that, uh, sorry to say, are getting left behind, because it's going to come mission critical to productivity. And really, at the end of the day, shareholders want to see how they're generating value. And if you're getting left behind here, you're leaving half and even more. I gave you the example of productivity in that large chemical company. They're one of the largest in the world. They actually described themselves as the largest in the world, the ND, and at 1%, I'm not thinking my word, you know. And the digital strategies they had, by the way, were largely still in the office space. They hadn't transitioned
Right.
into the or hadn't worked out their transition. And it was a great discussion. I don't want to give too much away, but we had the discussion how we can take that same sort of thinking in putting that digital backbone in place for their production and their control of their assets and creating those digital twins, as it were. Um, and really avoid going down those point solutions, which we'll talk a little bit in some subsequent questions, I'm sure.
That's a great point that you've raised. And for companies that might lag behind in digitalization, can you walk us through the process involved in building this digital twin? And what are some of the technologies that a company would need to invest in?
It is another great question. And to be honest, you can actually start anywhere. There's no one prescribed area you've got to focus on first. What I would say, and I would also say, you know, the advantages for greenfield are really obvious, but they're exactly the same for brownfield installations. Getting that retrospective data, we've got technology now that can take, base level documentation, let's say P&IDs and data sheets, and really contextualize those into intelligent P&IDs, even if they're paper-based systems. We can automate that through AI and our knowledge-based systems to bring in that intelligent data as that base layer. And how do you use that thereafter? But I think the number one message you want to get across here for this question, you can start in many different areas. No one size fits all, but I would start at the base layer of rudimentary information. If it was an open field and we could start anywhere, like P&IDs and data sheets and the likes. But it really is about the tool set you port that information into. Because if you end up with a data jail environment, right, you're not really extrapolating the value. There are many, many point solutions out there. The loads, they're very good at a point solution. And many customers go for the best in class point solution only to find that they don't have a digital thread strategy. Their digital data is locked in data jails. And if they can get it out, they lose contextualization as they move through the process. And every time you lose that contextualization, you're diminishing the value you're creating to your shareholders. So the strategy I'd say for customers is we can help you on a journey at any point if you want to, but the tool landscape is the most important point around how you create an environment where you've got that digital threading, as we mentioned earlier, right the way through from original design data, and we'll just talk about like the P&IDs and the likes and data sheets and how that's made available right the way through your build, implementation, your commissioning, your operations, and finally your maintenance. It amplifies the value at every stage. So my message is simple. Choose wisely that data set and how you get the position with that digital twin is made available across the entire life cycle. And I'll just give one other example. When I talk about life cycle, often we talk about workflows. And an easy way to think of this is like Uber. You think about the Uber ride app on your mobile phone. It's It's fantastic innovation. So what this does, I've got an app on my phone. It's got access to my personal data where I have my preferences, my ride types, and my star ratings and stuff, but also access to my bank account. And these are normally high security around these. And then I've got a marketplace out there of Uber drivers, and they can bid for my work based on my characteristics, and together with that, they can give me a price from where I am and where I'd like to go, and maybe some other options there. And by unlocking all those data jails and creating a workflow that's frictionless across the entire ecosystem of Uber, it works. Now, if one of those bits of data, it becomes a data jail, like I've got to send taxi driver's got to send me an invoice, I've got to send them a bank transfer, things start to fail, and those friction points create issues in that workflow. Now, I want you to think of it in a similar way to our ecosystem for a digital twin. When we're creating a digital twin, how you make that information across the entire workflow, it's so important. And that's the key decision a customer needs to make when they're investing. What's important to them across the ecosystem and those workflows? Because if they want to unlock value, they need to take all the friction points out of those digital threads.
Well, and Mike, I 100% agree with you. One of the things that we at Siemens realize is this question comes up again and again. John, where do I start? Mike, where do I start? And so we've developed a methodology to actually take a snapshot of your current distributed. You say data jails. Some of us may not be quite so judicious in our vocabulary. We may say data silos, data islands. Okay, because then when we say data island, you imagine a beach in the sun, and you're actually it's more of a positive view as opposed to data jail. But Mike, we've got the ability to actually take that current snapshot and also look at your business processes. And we have this. We basically survey the workforce, and what that allows us to do is then pull that data together. No pun intended, pull the data together about their data and about their ecosystem, and be able to provide them a very visual understanding of where are all these data jails, these data islands, and whether they have relationships or not. And then we provide a view of where would you want to be ideally. We actually generate that and develop that. So you understand what your digital backbone looks like. You understand where your integration points need to be. You understand how to create this traceability around all this federated data that you have at your organization. And it happens, right? I mean, people make investments as companies grow and investments are made. It by its nature, things become atomized, right? Things become federated across the organization. And it's very good to go, and on a regular basis, take a survey of that, and reestablish a better digital twin of your organization, for lack of a better term, right? To understand digitally what that ecosystem looks like and where should it be to be ideal. So when you talk about the digital journey, there's that to start with. I would say there's also a methodology to consider that complements what you were saying, Mike, which is you need to build the right foundation. Again, looking at the federated data you've already invested in. So, oftentimes oil and gas companies will say, well, starting back in the 80s, my company started to make investments. And then in the 90s, we rolled out ERP, and we have enterprise asset management. We have computerized maintenance management systems. We have CRM. The list goes on and on, right, of the acronyms we've created as a species around how we manage data. And they all represent various silos and islands of data. So I think about, number one, you need to get your arms around your business process. The biggest source of failure for ERP rollouts in the 90s was a lack of business process awareness. And so history is the great teacher. If you don't know what your business processes are and how to optimize those processes as you're making digital investments, well, then you're going to be throwing money at digital solutions and saying, why is my AI still hallucinating? Why am I still getting bad results? And then oftentimes with business process, there's organizational change management, because you're going to have to change processes because you've now taken humans out of the loop, or you've moved humans from this part of the loop into another. And so, you've fundamentally changed how you operate as a company, at the most granular level. And so I would say there's really kind of 5 stages, if you will, to this journey. And the first one is what I would call, configuration. You have to configure your business processes. You have to configure the way in which you do business to make the most of future digital investments. So you have to consider that. And then the next stage would be connect. So you have configure, and then you have connect. And I would say you need to then ensure that you've got a rock solid integration methodology to be able to pull, as you keep referring to, Mike, all this data that's in these jails, right? These islands of information, because now you'll get a bigger return on investment, right? I've invested in an ERP system. Great. If I can integrate that to my digital backbone so that when I have personnel in the field and I find that there's an issue, and so I need to issue a work order for labor, but that labor then entails tools, it entails materials, it entails equipment that needs to be ordered, all with my ERP backbone. If all of that is fully integrated and automated, and I've automated the mundane, if you will, um, then I'm truly driving productivity. But you've probably eliminated a lot of steps because you've automated your ERP system. You've automated and connected and integrated the field with the home office. And so, you know, Mike, the term I use to take what you just said is, first you have to reconfigure your business processes and take an audit of that, and then understand how to make sure that there are no data jails. You have a great integration strategy. That's your first 2 steps before you ever get into anything associated with the, digital twin, AI, and everything else, because now you have the confidence that you've got an authoritative source of truth. We often say a single source of truth, but that would infer, or that would imply, that everything goes into one single database. And that's not necessarily the case. What you have is an authoritative source of truth that's pulling from all of these different federated data sources, these data jails that you keep talking about.
Yeah.
It's that authoritative a source of truth that you're building when you talk about what you're talking about, building that right foundation going forward. Now, I will be able to enable a retrieval augmented generation, which is a fancy way of saying I will have the data that my future AI will pull from that I have confidence in, right?
Or
So,
compromise and
yeah, so
God,
the end in mind is you've got a hyper efficient, hyper productive company. But if you backwards plan, if you take yourself all the way back to the beginning, it's a current assessment of my current business processes, a snapshot of all of the digital that I've invested in, my snapshot of the lack of, or the integration that exists or lack of integration, and then what would be an ideal state for those digital investments to power my company, and then to build the necessary changes, both in the digital investments and in organizational change management necessary. And we have a methodology at Siemens for that.
yeah, yeah. I mean, in my early career, I spent some time at a consultancy, and we used to call it the brown paper exercise. Where you would map out the as is, and then the to be processes, because a lot of customers, I'll be very honest with you, don't actually understand the processes as they are, the as is. There's a lot of, should we say, minimal understanding or historical understanding, and that might not be that relevant. And if you don't understand this, and you don't understand what you want to change it to in the future, you're building waste. You're building unproductive steps. And I've seen this so many times. So these processes, this journey you talk about, is mission critical for any digital implementation that's going to deliver a digital twin. You can't just buy, going back to the question, off the shelf. You need to have a strategy for implementation that preserves that knowledge in such a way it's contextualized and brings the maximum value moving forward. Yeah, it's quite a journey. Great question again.
Circling back to your earlier comment, John, about workforce competencies, which is a vital point of discussion across the industry, as highly skilled technicians and engineers retire or plan to retire. Now, how can digital twins help plug this essential skills gap?
There's
I can take a first stab at that, Mike.
Yeah, well, you
You know?
go once. I've got a list as long as my arm on this.
I know, right? So, I'll take a unique twist at your question here, in that with the rate of inflation eating up everybody's retirement, I don't know that I sometimes wonder if any of us are going to be able to retire. But the interesting thing is, and I just saw this morning, there was a news story about how it's something like 65% of retirees are actually working full time, or something like that. And, they need to continue to make money. So when I think about the digital twin, so, let me bring it back to our conversation. So when I think about the digital twin and industry skills gap, I think about enabling remote mentoring, right? Something like that. So, remember I talked earlier about, the assisted reality that the digital twin gives birth to for personnel in the field. So, we've got challenges in the field. Again, as I said before, kind of a workforce competency shortfall that exists, both in, transient workforces and in people that are entering the workforce, people who may be switching to a new industry, and just inexperience, right? When you're young, the one thing you don't have is experience. And so if you think about the expertise that your quote unquote retirees have, and that is still something they can monetize and provide value for, I can quickly see for our species people with decades of experience now, because of, again, Starlink's everywhere, the Wi-Fi's everywhere, digital is everywhere. I can see a young professional. She's out at the wellhead, and we've got an issue. And very quickly, she's not just talking to AI, but she's also got remote mentoring that's available because of the digital ecosystem that's been invested in and created. Now, ultimately, we are training AI so that it can do more of that lift, if you will. But the one thing, and if history's any teacher, and it always is, I've never, technology doesn't necessarily replace humans. It forces us to take that next level of progression. So, we had whale oil, kerosene, and electricity. So, yes, whale oil was displaced by hydrocarbons. Hydrocarbons have been displaced by electrification. Does the person who's filling whale oil up for street lamps do they have fewer skills than, say, an electrician, a certified master electrician? You better believe it. But we still need lights. We still need that energy. The sophistication, though, of the human playing that role is much higher. And so I think with AI, and I think with things like what I'm talking about, this remote mentoring and then the training of AI as well to assist with an industry skills gap, I think what you're going to find is that humans aren't replaced, but there's a level of sophistication you need to have. But in order to get there, address this skills gap, you're going to have to still provide that digital means to bring the old and the new together and get that knowledge transfer. So to me, that's the challenge we see before us that is really massive, right? But it's the right question. But I think actually, ironically, a digital twin, the subsequent AI investments will actually help to close that skills gap more rapidly. They'll exist, but gaining the training and experience will happen far more rapidly and effectively because of digital investments.
Yeah, I mean, yeah, you had a very interesting view of it. I like your retirees. You worry me though, how many retirees are working.
Well, I saw that news this morning. I thought, my goodness gracious, right? But if you think about how rapidly inflation has grown recently and how it's, of course, now we're going to go off, we're going to get on a tangent, but, these are the real world influences that have a secondary and tertiary effect on your mindset around digital, ironically, right? And so I see opportunity. It's a challenge, but I see the opportunities that come out of that where, again, we're not losing all of this knowledge wholesale as people retire. The downside is people are still working, after they quote unquote retire. But the upside is there's huge value in that decades of experience that they bring to the table that AI does not have. I'll go so far as to say this, just as a bit of a tangent when it comes to skills gap and so forth. Humans and AI, I don't really see in competition with each other. I really see it as an opportunity to drive that next step of our digital knowledge, and I can't find the word for it, but basically that expertise that it's going to demand of us. And I think we as a species always find ourselves able to step up to the task. And so I'm excited to see what the next generation will be able to do with digital. So we'll work across the skills gap. We'll work to bring that competency shortfall, that gap, we'll close it rapidly thanks to our investments and so forth. But again, I think there's this drive around the retiring generation, but a means to better and more effectively convey to them the knowledge that the next generation needs to have because of the investments we've made.
Yeah. I mean, it's a really interesting perspective. And I want to build on that. It does build on it, so it is complementary, but it's a slightly, well, I think, different angle. If I look back to, if you look at the likes of AI and how it's helping the medical profession. Now, initially, there was a lot of talk about general practitioners, doctors being replaced by AI. And this didn't fly in quite the way people thought it might. Because, when it comes to your health, it's obviously a really valuable asset. Do you trust a computer or do you trust a person? At the end of the day, a physician, you can look in their eyes and the likes. And what we've seen there is, instead of replacing that physician, as you say, it's actually there as a co-pilot, almost an agent,
Right.
advisor. This particular patient, these are the test results, these are the possible options, these are the possible remedies. So it's acting almost as a guide, adding value, as it were, beyond just the physician might, because he hasn't got the time to read every journal, or she hasn't got the time to read every new medicine and treatment available. So it sits there and it gives them the guidance and offers that, if you like, that additional level of support. That's, it's hard for us all to take in. There's so much data out there. Now, what we've been building in recent times with our digital twin information is co-pilots that work in the same way. You want to build a hydrogen facility. What size is the hydrogen facility? What sort of throughput are we looking at? What's the sort of energy constraints in region? And the systems will begin to help you model that digital twin for the design process, the operating constraints, all the different scenarios that you might come across, to give you maybe a steady state and dynamic simulation, to give you the best possible options, so then you can make more informed decisions about what a design might be. So again,
Right.
we're not replacing people. We're actually augmenting them and overlaying with them with a lot of historical data that's hard for everyone to keep up to date with. And we're doing this right now in terms of a lot of tool sets. So those highly experienced engineers, you can think of the great engineers, but then we've got like 10 PhDs sat on the shoulders that are able to help them, inform them about what might be the best process design for all the different process steps that they might come across in this design. And that's really where we're taking it to, I think, the next level, because you can't have, there isn't enough PhDs in the world to have them at every project on every site. So we build it into the process, into the applications for digital twin design. And that's really unlocking, we believe, a lot of value. The other thing that we're finding, John, and again, this was, we're working with 3 oil and gas majors at the moment on how do they codify knowledge. You mentioned in an earlier question about, we are losing knowledge. We are. People are retiring where they can. The 40% that can retire or what want to retire might be, right? How do we codify their knowledge? And on these 3 oil and gas majors, they're looking for autonomous operations now, because these operations that, particularly in the oil and gas arena and the petrochemical arena, some of these processes are highly sophisticated. The operation staff are almost PhD level operation staff. And their concern is, scarcity of these people, and therefore they tend to be able to transient nature, move from one producer to the next. And they're saying to us, okay, how do we codify this? And can we get to autonomous operations? So the two big ones for me, these two were in the Middle East, actually, out of the three. One was it was the scarcity of operations staff, and they wanted to codify the knowledge base into autonomous operations. So maybe they've got 15 operators per shift, right? And they want to take that down to maybe 3 or 4, right? By codifying as much information as possible. But on one particular plant, where it's really a hazardous production facility, they almost want to deman the production because it's so hazardous out in the field. And they want to move to complete autonomous operations. And in that way, we're really having to build in, I'm going to say this, in our mechanistic models, how you would operate that production facility, and where we've got overlays and gaps in knowledge, we can fill in with some AI, but we've got to be really careful on the hallucinations here. Because, and this is what a lot of people, everyone says, you can just throw AI at this, you can throw AI. You don't want to throw AI without guardrails. So you need fundamental, I'm going to say, mechanistic, physics-based models that are the fundamentals of our digital twins, and overlay with data models. And we talk about big data models, but what we really mean are, our data sizes, we might think they're big, but they're not big enough. The small data models. So it's how you use those. And that's another example of where we're seeing, how we're dealing with those retirees and those high potential environments in the future. It's going to be quite an interesting journey, this, because, since we've been on with these 3 projects, the amount of other customers that have come to us and said, how far can we go with this autonomous operations, and how far can we go with the training of new staff using AI? And that's another interesting one. We built a lot of platforms recently where they're using the platform to provide a virtual reality environment to not just train operations staff, but to train maintenance staff in those high potential environments. And those training courses that they develop, they then move on to certified, qualified staff to carry out those operations in the future. So they're not just, we're going to train you. No, we're going to train and test you to make sure that we're operating in a safe environment, and we carry out safety through the entire life cycle. And the digital twin is providing a backbone to that.
Talking of opportunities, sustainability is a major point of discussion across the oil and gas industry. How can digital twins help, especially with reducing emissions?
I can have a go at this one, Joe.
Yeah, go ahead.
I mean, this is a really interesting one. So we get a lot of discussions on this about sustainability, and it comes in lots of different flavors. But if I just take the one that's probably on everyone's mind's eye, when they talk about, sustainability targets, they probably talk about carbon footprint. And, even as oil and gas producers, the whole value chain of extraction to production, they want to get to net zero, a lot of companies. And how do they get there, and how we can help them? So typically what we will do, we will work with them on creating a digital twin of their process and their energy requirements to optimize that process. Now, a lot of companies have already got an optimizer in place, but then it becomes about fidelity. How close does your digital twin model to the real plant? It's the fidelity of the virtual to the real process plant. And that's where we see a big gap against some of the options that customers might look at. So you can look at a digital twin and you say, right, I'm going to go for an optimizer, but you might be leaving so much value on the table if the fidelity isn't that close to the design constraints and the operating envelope as what you might deliver. And we're typically seeing, if a customer's already got an optimizer in place, we can still get up to 5% more productivity out with a high fidelity real-time digital twin. And that's the other thing as well. So you can create a digital twin, but can it run real time? So these twins have got massive calculations behind them in real time. So to be able to operate in real time is a real challenge. Now, our twins, we can operate those at real time and operate and guide those customers through that operating corridor. And I'll just give you one example. We did a large oil and gas network. It was a master gas network in the Middle East. And this system has thousands of assets, literally thousands of assets and thousands of constraints. We modeled the entire system. And when they looked at what modeling was available, they actually determined only Siemens modeling environment was capable of doing this real time, John. We were the only ones that could offer this real time.
But of course,
It's a huge asset. And what that develops, that actually guides them into operating corridors. So the digital twin runs next to the real process. It runs in parallel. And we call it the executable digital twin, John, right? So it's running next to the real process. And it's gathering all the real-time information and it's saying, okay, how do I move these assets into this corridor of operation? It's just too many parameters for a human to think about.
Right.
So this calculates and says, right, and I can't give thousands and thousands of instructions real time to this operation staff. So what we do, and this is one's running an open loop, this instance, because it's a critical asset and they wouldn't want to close a loop. So it says, right, these next 10 changes will move you into this corridor of operation, right? And that delivers a value, just to put things on the table, of around about $100 million a year in terms of value without any capital outlay. That's just an executable twin, digital twin, running in parallel to the real process, guiding them about what changes they need to make to move into that corridor of operation. And here's the getcha, right? That the digital twin can be configured to say, right, I want to maximize yield. It can be configured to say, I want to maximize yield with this pipeline down for maintenance or reduce it. And maybe we've got to put it on to 20% production maximum because maintenance regimes have limited what we can do there. But it could also be, I want to minimize the amount of energy. I want to look at my energy management system and compare it to maybe hydrogen, solar, wind, and manage the energy associated with this and still get to that towards carbon neutral for extraction and production. So it really is an exciting space, this, but it just gives you an example of that. Now that's a mega example of what we can do, but it's delivering real value. And by the way, we estimated, that was the customer telling it was around about $100 billion worth of net present value. We estimated it to be much more than that, but it's just a great example of what you can do with these twins when you move into that execution mode. So, John, I don't know whether you've got any more to say on this.
Well, the only other thing I would say is you've covered kind of the systems approach to looking at, reducing things like carbon footprint and other waste and so forth. When you have a digital twin as part of your design process, for example, when you are looking at your supply chain and where you're sourcing and the quote unquote carbon footprint or the sustainable posture of your suppliers in that supply chain, because you've invested in requirements management that's integrated to your design process, you can ensure that your engineers are selecting always the right material or the right parts and components that go into the design that can balance and optimize both your sustainability and profitability and availability, from your supply chain. So you've got all of these factors to consider. So it's a great question. But sustainability, I see sustainability as akin to profitability. If you're reducing waste of any nature, could be carbon dioxide, could be, flaring or, anything like that. Anytime you drive a more sustainable posture, by its very definition, from my perspective, you're always driving profitability because you're seeking to eliminate noise in the machine. You're seeking to eliminate waste of time, waste of material, right? And when you eliminate waste,
Oh,
you're driving profitability. So, the digital twins are phenomenal at being able to, if again, you've got the right foundation, as we talked about earlier, and so your ERP system and your design systems and your, productivity systems, if you've got the necessary integrations and business process flow to support the right kind of decisions, and in this case, as you were saying, Mike, sometimes the system is so complex, it's overwhelming, and a human couldn't necessarily be the one to control it all. So you create reduced order model, executable digital twins, which, just for everybody's understanding, when you reduce the order of the model, right? Reduce the order of magnitude. You may say, for this pump, there's an inordinate number of variables that can possibly affect its performance. But what we find is there's really only three I need to be thinking about, really, that represent 90% of the influence on this pump. So what I want to do is I want to take away all the other variables. It's not that they're not part of the digital twin, but for the sake of decision making, there's really three that I need to focus on. And if those fall outside of certain parameters, then I have to take the following actions. And I don't need a human to make that decision because I already know what needs to be done. So there's an optimization from automation using reduced order of magnitude modeling around our executable digital twins, where I help put at the edge, at the point of operation, that decision making that I know is the right decision outside when things fall outside of their given parameters and so forth. So, and then you do that at scale, right? You've got these executable digital twins, right? These let's say mini digital twins, right, that exist all throughout the system, working in concert together. So now you're driving, and Mike, we were in the Middle East and we were talking to a customer about that, which is they had like, I think it was 12% of their product was bad, and so they needed to improve their yields because inputs coming in would have variability, and then they would need to tweak everything down the line, quite frankly, to get the final product to meet a certain grade of, I think it was like polyurethane or whatever. But the point was, he was like, I've literally got to turn knobs and I've got to, flip switches and everything and make decisions on my admixture to get the right product at the end of the day, all the downstream effort that has to go on. And I just can't move fast enough to attest to that. So I need a stronger digital twin of my entire process. And to your point, we have to be able to deploy these executable digital twins at key points along the process route that are empowered to make the necessary calibrations to optimize the entire system. So again, I think it's a great example of humans and AI working together to complement one another. So it's very powerful. So, we've had real examples. It's a great question. We've had real examples of how we've been able to help customers eliminate a tremendous amount of waste. Another example would be not just waste of material, but waste of time. Mike, I think you talked about it earlier where you have disaggregated workforces, right? So you'll have companies, they've got offices all over the world. Of course, we're all on teams and everything like that. But being able to collaborate with a digital twin, we've actually measured a reduction in 40% of the man hours necessary to go through the design process. So customers have said we've seen 40% improvements, right? I mean, think about that. I mean, that's to an engineering organization to be able to do far more in a given amount of time and drive profitability like that is incredible, right? So again, it's sustainability of your environmental posture, and it's also sustainability and productivity of your uh, call it workforce posture, right? And so I'm excited about both of those getting positive effects from the digital twin.
Yeah, yeah. I mean, I'm sure we'll talk about that in the next questions a little more, but there's a lot of value that we generate that, you talk about 40%, that's a huge amount of value.
Tremendous.
It is. But it's not just that, when we talk about that value, it normally equates to time saving. What took, 100 days is now like 60. You've really, you've brought more value, the productivity is. But you've also got improvements in quality, right? You've got better use of capital as a consequence. So there's a whole load of additional parameters that come alongside that we that often customers don't realize is still on the table that you're going to bring more value to the business with. It's, anyone that moved away from 40% would be nuts, but it's probably a lot bigger than just the 40%.
Thank you so much for joining today.
Thanks for having me.
Thank you.
Thanks for joining, and I hope you really enjoyed this episode. Don't forget to follow us on social media, and to get more episodes like this and more comprehensive coverage of the energy industry, you can go to energyconnect.com. I'll be back with the second episode of this very special series brought to you in partnership with Siemens Digital Industries Software. See you soon.